Every day, millions of cars take to the road. But under the hood, two completely different engineering worlds are at work: gasoline and electric. Meet Alex, a mechanical engineer, and Maya, an electrical engineer. Together, they will show us how these engines actually work. A gasoline engine is a thermal engine. It creates motion by burning fuel inside a closed chamber to unleash high-pressure gas. Most car engines use a four-stroke cycle. First, intake pulls air and fuel in. Next, compression squeezes the mixture tight. Then comes power, where a spark plug ignites the fuel, forcing the piston down. Finally, exhaust pushes the leftover gases out. Up and down piston movements are converted into rotational motion by the crankshaft, which ultimately spins the wheels of the car. But there is a catch. Gasoline engines lose up to 70% of their energy as wasted heat and sound. Now, let us look at electric cars. Instead of explosions, they rely on electromagnets and electricity to generate smooth movement. Inside an electric motor are two main parts: a stationary outer ring called the stator and a spinning inner core called the rotor. Alternating electric current flows through the stator, creating a rotating magnetic field that constantly pulls and pushes the rotor around. Electric motors get their energy from a floor-mounted lithium-ion battery pack, managed by a power inverter that controls speed. Electric motors are remarkably efficient, converting over 85% of their electrical energy directly into wheel movement. Electric motors deliver instant torque from 0 RPM, meaning they do not need complex multi-speed transmissions like gasoline cars do. Electric cars can also reverse the process. When braking, the motor turns into a generator, sending energy back into the battery. A traditional gasoline engine has hundreds of moving parts like valves, belts, and spark plugs. An electric motor has just one main moving part. Gasoline vehicles refuel in minutes at gas stations, while electric vehicles recharge using grid power at home or fast chargers. Thermal engines rely on chemistry and thermodynamics. Electric motors rely on electromagnetism and battery technology.